All right, today we're going to talk about the skeletal system more on the microscopic level. So yesterday we talked about bones and joints, and today we're going to talk about cells that make up bones and the structures with the way the bones look inside. So bones, while we think about bones as being almost, I don't know, when you think about death or someone dying and you think about skeletons, you kind of think of this hard, rigid structure, and it is. But while you are alive and you have blood flowing through your system, your bones are very much alive. They're making cells, those cells are dividing, some are dying, some are being reproduced, and they do different things for the bones. So I want you to try to not think of your skeletal system as just this big chunks of calcium and other minerals. There are cells that are constantly working to keep your bones healthy and fresh and strong. So first thing we're going to talk about is osteoblasts. And like we did yesterday, I want to point out some of the pages in your book. Page 418 has a good image of the inside of your bone. And so when I talk about that, I'll be referring to this diagram on page 418. So osteoblasts, these are cells that replace disintegrating cartilage with something called spongy bone. Now, sponges, if you think about a sponge, you think about it in some cases being soft, but that's not the case here. It's not soft bone. It just appears to more look like a sponge, not necessarily feel like a sponge. So it's got the holes and it's pitted. That's why it has that name. So in the meantime, you have other osteoblasts that lay down compact bone. So you have, if you look at your textbook, let me get this in the picture here. All right. And may not be able to see the images, but this again is on page 416. So this is the spongy bone. Can you see that? Let me move over here. In here, there's the spongy bone. And you can see it has that pitted kind of spongy look. And then on the outside of that, surrounding it, is the compact bone. And osteoblasts are working on replacing that as needed. So that's what the osteoblasts do. Now, within that compact bone, you have this blow up. Oh, I always go the wrong way. Right here. Okay. And there are structures that are called osteons, and you'll see those are the circular units within that spongy bone, or compact bone rather. Then you have the lamellae, which are layers of hardened matrix, and both of those are labeled on page 418. Have I been saying page 416? I meant page 418. Those are labeled for you on page 418, and so you'll see that the circular osteon is outlined for you, and then you'll see where it's pointing to the lamellae. Okay. Then we have osteocytes. Now, if you're not picking up on the term osteo refers to bones. So osteocytes are located between the lamellae. So go back to that diagram. If you don't remember what that looks like, go back to that diagram. And so then you have osteocytes forming bone there. Now, if you look at that diagram again, that blown up version of what's going on within the bone, you'll see the Haversian canal. And those are passageways within your bone where blood can travel and carry nutrients to your osteocytes. Yesterday, I mentioned a couple types of bones, like broad generalization of bones. I mentioned short bones, like in your fingers and wrists. And I mentioned flat bones, like your ribs. And then we talked about long bones. So a long bone has two basic parts. So again, I'm going to kind of try to hold this up here so you can see it. This is in your book. So you have the long bone. The long middle part is called the diaphysis, sometimes referred to as the shaft of the bone. That's where the compact bone is, and the ends are the epiphysis, and that's where the spongy bone is. Now, between those two places is your growth plate. My growth plate is not active anymore, and you guys are approaching the point where your growth plates will not be active. So that's what allows your bones to grow. So the bone doesn't grow here in the middle. It grows along the plates between the epiphysis and the diaphysis. So that's the part where the growth occurs, and it moves, it gets longer from the ends, not in the middle. Another type of cell are the osteoclasts. And sometimes you need to get rid of new bone and rebuild it. And so that's what these guys do. They destroy the inner spongy bone so that then your osteoblasts and your osteocytes can go in and form compact bone. Because sometimes it just needs to be replaced, just like your skin cells, they have to be replaced. So do your bone cells. All right, so the overall function of the skeletal system. Well, think about how it protects you. Where does it protect you? What is it, things that you have bones that are covering, okay? So if you think about your brain, very important to protect that. So we have a skull. You have your spinal column, your spinal cord that runs within your vertebrae. Those vertebrae protecting that spinal cord. And then you have your rib cage, which protects many of our internal organs, hearts, lungs, intestines, reproductive organs. And another thing that they're used for is our storage site. We have to have calcium, for example, and bones are our storage place for that. Now, bone marrow. This is where your red blood cells are made. So, and some white blood cells. So think back to our immune system. Here's a way that they're related, and that one relies on the other. So you have red bone marrow, which makes red blood cells. These are within your bones. And there's a picture of this on page 420 in your textbook. At the top of the page, you'll see where it's located, where this bone marrow is and where it does its work. So red blood cells, platelets, and some white blood cells. Now, at birth, all you have is red marrow. As you get older, you start to develop yellow bone marrow, and that is most of your diaphysis is yellow bone marrow. And this is where you make your white blood cells, which are, we talked about being important in your immune system. All right, we will stop there today. That basically concludes our discussion of the skeletal system. Tomorrow, we will pick up with the beginning of the muscular system.